So today we did transformations with h comma k, cubic, and square root functions. So for cubic functions, the first thing that we want to know is, okay, so we look at this and we say, oh my god, what's happening? We say, okay, we know this is a cubic function because it has a cube right there. We know that a cubic function looks like an S, kind of, like that shape. And we look over here and we say, okay, we have h here and we have k here. We do the opposite of h, so our transformation is going to be right 2 and up 1. So our starting point is going to be 2, 1, or our vertex. Okay, so we have our table of values once again, 0, or x, y, start at 2, 1, go down 2 points and up 2 points. Plugging 1 in for x, we get -1 cubed plus 1. So plugging 1 in, we get 1 minus 2 cubed plus 1, which gives us -1 cubed plus 1, which gives us 0. For 0, we get 0 minus 2 cubed, which gives us -2 cubed. -2 cubed plus 1 gets me -8 plus 1, which gets me -7. And when I plug in 3, I get 3 minus 2 cubed plus 1, which gives me 1 cubed plus 1, which gives me 2. And when I plug in 4, I get 9. So we already have this plotted. These are not going to be the same because cubic functions and square root functions are not symmetrical about our origin. So we're going to come over to 2, 1, then we have a point at 1, 0, and then we have a point at 0, -7. Okay, then we have 3, 2, and 4, 9. So our graph looks like this. Our domain is -infinity to +infinity. My range is -infinity to +infinity because they go left and right, up and down forever. My x-intercept is 1, 0, where it crosses my x-axis. My y-intercept is 0, -7, where it crosses my y-intercept. Okay, for this example, it's going to be the same thing, but we just moved down 3 because we have no h, so this is k. Our starting point is going to be 0, -3, down 3. So we go to 0, -3, and we have our vertex. Then we have our table of values. Starting at 0, -3, we can go to -1, and we can go to 1. Actually, we should do 2 for this one. So plugging these in, I get -2 cubed minus 3, which gives me -11. I have -1 cubed minus 3, which gives me -4. I have 1 cubed minus 3, which gives me -2, and I have 2 cubed minus 3, which gives me 5. So I plot these. I have 1, -2, and 2, 5. And then I have -1, -4, and -2, 11. My domain is -infinity to +infinity, same with my range. My x-intercept, where it crosses my x-axis, is at 2, 0, and my y-intercept is at 0, -3. Writing a parent function that shifts a cubic parent function shifting up 8 and right 12. This is k and this is opposite of h. So we get y equals, we know we have a cubic function. We go up 8 units and we know that we are doing the opposite of 12, so we want to go minus 12. Shifting to the right would give me minus 1, okay, opposite of h. And there's no k here, so there's technically a plus 0, you don't need to write it. Shifting down 4 would be y equals x cubed. There's no h in this case, so down 4 would just be minus 4. Looking at square root functions, we know that our square root looks like this, and we know that we cannot have square root of a negative number. Okay, we also want to use numbers with perfect squares to graph. Okay, so we have h and we have k. Our transformation is going to be right 3 units, right opposite of h, and up 4 units. My starting point is going to be 3, 4. So I have a table of values. I know that my starting point is 3, 4. We're not going to go any more to the left than that because our function only goes to the right. So then we can do we can do 4, 7, and 12. And the way that I got these is we have the square root of 1, the square root of 4, square root of 9, okay? And these numbers are my parent graph. But we need numbers that when we subtract 3, we're going to get square root of 1. So for this example, we have the square root of 4 minus 3, okay, plus 4. That's the square root of 1. Adding 4 is 1 plus 4, which gives me 5. For this example, I want the square root of 4 to give me 2, right? But I have to subtract 3 from it in that square root. So in order to get me the square root of 4, I need 7 minus 3, which is going to get me the square root of 4 plus 4, which is 2, plus 4 is 6. And then same thing here, I want the square root of 9. 12 is 3 more than 9, so I have this 12 minus 3, which is the square root of 9, plus 4, which gives me 7. So plotting that, I go over 3 up 4, that's my vertex, and I have 4, 5, and then I have 7, 6, and 12, 7, somewhere up there. And that's what it looks like versus the parent graph that starts here. So this is what my parent graph looks like. My domain in this case, my lowest x value is x equals 3, and it goes to positive infinity. My range, so my lowest y value is 4, and it goes to positive infinity. I have no x-intercept, and I have no y-intercept. For this example, once again, I have h and k. My transformation is going to be left 1, and it's going to be down 3. So my starting point is -1, comma, -3. I have a table of values. I know my lowest is -1, -3. We want to get the square root of 1, the square root of 4 here. So taking 0 plus 1 will get me the square root of 4. So if I use 0, then I'll have the square root of 0 plus 1 minus 3, which gives me 1 minus 3, which gives me -2. If I want the square root of 4 here, x can equal 5. So I'd have the square, oh, just kidding. X can equal 3. So I'll have the square root of 3 plus 1 minus 3, which gives me the square root of 4, which gives me 2 minus 3, which gives me -1. So I come over, I have -1, -3, 0, -2, and then I have 3, -1, and that is my function. My domain is going to be -1 to positive infinity, my lowest x value, and then my lowest y value is -3 to positive infinity for my range. My x-intercept is this way. It looks like, well, we probably could have kept plotting. It's supposed to be more like 8, 0. It looks like 5 here, but, and my y-intercept is at -2. Writing a transformation from this parent function, up 1 is k and right 3 is opposite of h. So we know we have a square root function, and we do the opposite of h inside of my function, and I'm going up 1. Shifting left 9, this is opposite of h, and up 5 is k. I'm going to have the square root of x plus 9. Up 5 is plus 5. Okay, shifting right 1 is going to be the opposite of h, and we have no k, so we can just leave it out. So here I have y equaling the square root of x minus 1. Shifting down 4, we're going to have the square root of x minus 4, right? This is my k.